Hello everyone. So this notebook demonstrates the Fund 8 project Decentralized Physics Simulations. We'll walk through 3 official examples of the milestones plus an extra ring polymer molecular dynamics showcase. So all workloads are tiny, CPU only, and wrapped in Docker to keep the demo deterministic and simple, to highlight how you containerize certain physics environments so it can be run on NuNet and Cardano eventually. When NuNet's compute marketplace moves from the alpha to beta, the exact same images will run out of the box on volunteer nodes, or you can update them if you want. So we have basic code examples here and some examples that we'll look at in Jupyter Notebook. So basically, milestone 1 demanded that the proof that classical and quantum code run inside our framework. First, we show that we can run OpenMM and Longevity Dynamics on a single argon atom in a harmonic well. So we can see that this trajectory over time shows that it relaxes towards 0. And basically, the second cell shows that we can do quantum DFT calculations using pi SCF for a water molecule in this case. So basically these show that we can both run MD and quantum chemistry in these Dockerized containers. And milestone 2 is all about AI, and here we show that how you can containerize, for instance, a torch Annie neural network potential, compute forces and perform for instance, just one of the gradient steps that you might see in MD simulations. So what we see here is that we can look at the DFT calculation from before, but we can also look at the Annie before and after the gradient update. And basically, this is what you want to do when you do some sort of equilibrium optimization. And again, this is a working example on being locally run. But it highlights that if you want, you can extend this to more complex systems. And milestone 3 is all about distributed simulations. So here we show that you can run multiple Docker containers in parallel. And for instance, in this case, we're just doing it with a Leonard-Jones potential, but computing these energies in a parallel way that each uses a different Docker container. So you can imagine that each of these runs on a different node. Basically, the results stream back from a Python queue back to this notebook, which is again is a simple example because we are showing this locally, and so you can see that it runs with a number of different containers all at once, and it brings it together, and we can evaluate some analysis from this. We see the Leonard-Jones potential and how you basically can create a cubic spline of this, which is basically an analytic continuous energy function based off of these data points, and we show how you can compute the forces based off of this spline in different runtimes based off of this containers. And also, we show how we can either containerize a single ring polymer molecular dynamics simulation and show various different dynamics. But also, we show how these same things can be done in, again, a distributed way where we have different computations being run on various, in this case, containers, but in the general sense, these can be run on distributed nodes. And and the last thing we show is basically a similar thing where we do some quantum chemistry calculations also being run in a distributed manner, and we calculate the energies, so we can basically find the lowest energy conformation of this butadiene chemical. And so basically everything you've seen is intentionally basic. The goal is to meet and showcase these milestones and how exactly we would do them in a more general, global, and decentralized fashion once we completely port over to NewNet. Um, yeah, but the heavy lifting is still ahead in the integration. So mapping our internal schedule to the NewNet's job API and wiring the Cardano reward contract and scaling container counts from single to digits to hundreds. So those are all things that we're looking forward to. But yeah, if you take one thing away from this, let it be that high performance science can be packaged as tiny and self-describing Docker jobs in very simple cases. And if you so we'd like to thank the Catalyst funding, and watch and hopefully support us for unconventional research and development in the Cardano ecosystem.